Hey everyone, Mr. Fransky here. Going to take a look at problem 2 here about testing a Poisson distribution. So we are told that one of Amazon's customer service platforms is to have a customer service agent make a phone call to their customers to help with solving a service problem. Amazon.de believes the number of phone calls follows a Poisson distribution with a mean of 2.3 calls every minute. All right, so we have a Poisson distribution with an average of 2.3 calls every minute. To reduce the need for person or people operators, Amazon.de introduces an online chat service that uses AI to answer most queries. Seems smart. In order to test whether this online chat service has reduced the number of phone calls over a randomly selected hour, the number of phone calls were counted. So 2.3 was per minute. So in an hour, we would expect the average to be 2.3 multiplied by 60, which is 138, right? So null alternative hypothesis. Well, the null hypothesis is going to be that the average is 138, all right? So they believe it follows a Poisson distribution. We're just testing to see if the average has changed, right? So 138. And then the alternative, so they use the word reduced a couple times here, right? So they want to see if we have reduced the number of phone calls. They also say to reduce the need for people operators, right? So we want to see if this has gone down. So has our average gone down? So we'd expect 138. But now with the chatbot, they're going to see if the average has gone to under 138, and we're going to have to find a critical region and test the p-value, all the stuff that we usually do with hypothesis tests. So average is 138 or average is less than 138 is what we're looking for. Calls, let's say in 60 minutes. So calls in 60 minutes. Okay, so the distribution X under the null hypothesis, so we have X is Poisson with an average of 138, right? 138 because it's the number of calls in an hour. So now the critical region. Well, we're hoping that we get a number less than 138. That's going to help us reduce or reject the null hypothesis. So just like with our binomial, right, we could have 0 calls. That's basically going to have nothing, right? They could have 1 call, could have 2 calls, 3 calls, 4 calls, but we expect 138. So by the time I get into like the hundreds, right, maybe I've got some probabilities, okay? And eventually it's going to go up and it's going to come down. And we're trying to show that we've gone down. So there's going to be some number that we cut off here. I'm going to make up a number. Let's say this is x and this is x plus 1. So there's some number where less than or equal to x. There's some value. This is where going to be our critical region. There's some number where if we're less than or equal to x, so if we are less than or equal to x calls in that hour, we will reject the null hypothesis. And remember, we want this to be at a 5% level. Right? We want this to be a 5% test. So just like with our binomial, we're going to look for the first value that's under 5%. So all I'm going to do here is I'm going to go to my y equals. I'm going to drop in a distribution. And I'm going to do Poisson CDF because I want x or less. Right? So 0 up to x might be a better way to think about that. So I'm going to do Poisson CDF. And our average, excuse me, is 138. I'm going to do a comma, and then I'm going to do an x. Because what that's going to tell me is the probability of up to 1 or up to 2 or up to 3 or up to 4. And I'm looking for the value that gives me less than 5% for the first time. So if we go into our table here, if I look at my table set, see I have it starting at like way low. If I go to the table, I mean the probabilities at the beginning are basically going to be super small. Yeah, see we have like E negative 56, E negative 58. Like they're teeny tiny because if you expect 138, there's no way we're going to get like 0 calls. So in my table set, maybe we start at like 100. Right? So maybe I start at like 100 here instead of starting so low. And I'm probably still going to have pretty low numbers. So you see though now, like we're at E negative 4, E negative 3, and then we are into actual decimal values, right? But I want the first value that's under 5%. Okay, here we are. Look at this. So the probability of getting 115 or less would be about 2.5%. The probability of 116 or less would be about 3%. Probability of 117 or less is about 3.7%. Probability of 118 or less is about 4.5%. Probability of 119 or less, now we're over 5%. So 118 looks like my critical region. So the critical region the critical region will be if the number of calls that I get is less than or equal to 118. If I get 118 or fewer calls, that means that I have truly lowered the average. I've gotten that less than 138, and that's because we got that point under 0.05, right? We want this to be less than 0.05, and 118 gave us that 0.0458. I'm going to take a quick screenshot of that so we can keep it. Put it right here. So again, being able to kind of manipulate this table in your calculator is probably the most important thing for being able to do these binomial and Poisson tests. The difference between this and binomial, they'll tell you it's Poisson, right? They're not going to just kind of give you information. They have to use the word Poisson in order to be able to do this kind of a problem. All right, so if this test is adopted, say the actual significance level. Well, we want alpha to be 0.05, but in actuality, we just saw the actual alpha is going to be 0.0458, right, which is a little smaller. And just like we said with the binomial, this is the probability of getting a type 1 error, right? It's smaller than 0.05 because on a normal test, your probability of getting a type 1 error will always be exactly alpha. That was a bad arrow. Let me do a better job. Right? It'll always be the exact alpha value because that's the odds of getting a number higher than the critical value. But here, if we get it 118 or more, the probability of that is 0.0458. It's not 5%, right? So that kind of changes our ideas a little bit about type 1 error because it's a discrete distribution. We can't get a number between 118 and 119, right? It's either 118 or it's 119. We reject or we don't. So using your critical region, if the total number of phone calls received over the 1 hour period is 119, is there evidence at the 5% level that the number of phone calls has been reduced? Well, you can actually see in our table over here that the probability of getting 119 or less is actually over 5%, right? So that's not in our critical value. We found the 118, and so we know because 119 is greater than 118, it is not in the critical region. Not in the critical region. So we do not reject the null hypothesis. So we claim insufficient evidence that the number of calls has reduced. Number of calls has reduced, right? And it's a heartbreaker, right? I'm just imagining like someone doing this test. They're like, oh, we're at 116, we're at 117, we're at 118. It's been like 58 minutes. And then they're like, ooh, we're going to reject it. And then the 119th call comes in, and they're just like, oh, man, and it's still like it's super close, right? Your p-value here, would be just Poisson CDF at 119 with an average of 138. And we have that on our list here. That's 0.055. But because that's greater than our p-value of 0.05, we do not reject the null hypothesis. And we claim that the average has not statistically significantly changed. And that is how you test a Poisson average.